Hey, thanks so much for having me. This is going to be a brief introduction of what entropy is, where it comes from, and then we are going to end up leading to the workshop that we're going to have after that. So, first things first, what is entropy? Well, it would be bad if I didn't start with this story. So, let me tell you a little bit about how entropy came to be. My name is Phil. My co founder, Rodrigo, and I have been working on entropy for going on 2.5 years now. And the first thing you need to know about me is that I've been playing this game for a little time, a little older. So I've been writing code since professionally since like '99. And I've always been very technical. I've done a lot of work around microservices, distributed systems. I've built engineering organizations, but I've also built technology for companies like SoundCloud, DigitalOcean, Meetup, SeatGeek, Buoyant, and others. But one thing that has happened as I became a little older is that I actually became what we sometimes call post-technical. So I started spending a lot of my time working on building organizations, teams, and the engineering manager, director, CTO role that I've had over the years. And something that happens when an engineer ends up on this role is that you end up missing a lot of your tools. So there's a lot of tools that you're used to as an engineer. You have your IDE, VS Code, IntelliJ, what have you. And when you're working on basically like leadership tasks, it's almost nothing. You have templates, maybe there's like some tools that do things here and there, but you don't really have the level of integrated productivity you get from an IDE. And that's what I wanted to do. I've been trying to buy this tool forever, and finally I had some time like I'm going to start a company, and that's what I'm going to do. So that's how Entropy started. We actually did build what was the VS Code for everything, um, but it was kind of harder than we had first expected. These are actual screenshots from the system. Most of them, I think, were like with users, some were testing, but you can see that, just like everybody, we were having all sort of different problems trying to make AI technology work for us. And it's been fun times and some awkward times when we had our users. One thing that was interesting, especially around 23, various different versions of OpenAI's models would, if you just started using it for long enough, would just start talking about COVID. We never figured out why I was talking about COVID when, it's just in an engineering stand-up meeting, but it would happen very often. So we had to deal with a lot of this kind of hallucinations, just useless output, and things like that. And if this was already hard, like this is basically the same feature that we're seeing here is summarized from Slack. That was our first feature that we first implemented. Like you can imagine that it got only worse when we actually got to a point where we were working on the most valuable features for our system. So this thing here is great, but that's not what we sold our users or investors. What we sold them was this, the kind of automatic kind of ability that you have on IDE, but for everything else you do. This is something I guess we would be calling it an agent today. We did not use that word back then because we were a little more strict with what the word agent meant. But ultimately, that's what it is. And we did, like I showed you a little clip of what the tool looked like. We did end up building this, but we trial and error, many iterations, and we ended up with a lot of AI pipelines that look like this. This is actually a screenshot from one of them as I potted between systems. But there's a lot of different components and there's a bunch of acronyms and research papers that you need to read to understand each one of these things. And inside them, there's like more complication and they have to kind of be arranged dynamically. It's a whole thing. Um, but it did work. We got to about 11,000 users, 10,000, 11,000. 40 companies were using it. We were 10 times better than Slack on our own benchmark, but there's a blog post there that you can read that discusses it a little further. And honestly, I miss it every day. I manage a much small team now. We are like 4 people working on our company. I came my previous job. I was managing 1,700 people, so I needed that more back then than now. But still, like I miss it every day. I can say it. And one day somebody's gonna build this thing. It's not gonna be us for reasons, but we learned a lot. And the first thing we've learned is actually that the worst thing to do when you're building an AI app is to build these large monolithic and overcomplicated pipelines. Basically, this happens when you are trying to solve, you have a features, meeting schedule or whatever, and you try to solve everything with one pipeline, integrating multiple different techniques. I'm going to use this re-ranker, this model, this fusion, that agentic, this, and you end up with a system that's overly complicated, very hard to test, very hard to validate, very hard to operate, which is something people don't really talk about as much with AI. Nobody talks about what happens when this stuff goes to production. But ultimately, it's a very complicated, and honestly, for this audience here, where we all software engineers, we've had experience building software in many different ways. I can say that this is very similar to just building a huge monolithic system. Monolithic systems have their places, and there's advantages in building them. But ultimately, if you're building a very, very complicated system, you might not want to build everything as one function, everything as one class, what have you. And that's kind of what we're doing with AI when you're looking at things like this kind of stuff that we built. It was on trial and error, so we didn't even have a methodology to get this. So okay, no monolithic kind of pipelines. What should we do instead? Well, our experience has shown that the best way to go about building AI systems is just to follow good, honest software engineering practices, namely break it down into smaller tasks. So we actually like the word task a lot. You're going to hear a lot of task within Altropy. But the idea really is that when you get something hairy and weird, like book a weekly meeting every Monday with everyone to sync on project issues, you need to break down on what each one of these things mean. You need to ingest the data from projects and blah, blah, blah. You need to classify each employee. Do they belong to this kind of project or not? You need to then recommend a better time, a good time on a Monday. You might need to classify again, so use the same task but in a different way. Issues from Jira or Linear or whatever is relevant to that project or not. Maybe they're not on the project. Maybe the project doesn't have a dashboard. The project is spread across different data sources. It happens a lot. And then you generate a proposed meeting agenda, just cherry on top to make your users happy. And wow, AI, that's totally worth the extra $5 a month I'm paying per seat. Anyway, so we do that's how we built our system. That's how we recommend doing this. One of the reasons is because instead of having one single hairy pipeline, you have a few different instances of simpler pipelines. So this is most pipelines we are working with now, they have maybe one or two forks, but they're not really widely forked. As opposed to what we saw before. They're easy to manage, they're easy to understand, they're easy to evaluate, and easy to maintain and operate. But there's something that's interesting too, because even if these pipelines are simpler when you look at the topology, which is basically the architecture of this pipeline, you need to not be fooled by what you're looking from the outside, because once you double click on this, you're going to see, there goes my effect. You're going to see, once you double click on this, you're going to see that inside each pipeline, there's a lot of different components. And there's different tools, there's different algorithms, different models that it uses. And you still need to configure and pick each one of those. So that's where Altropy kicks in. That's why we're here, basically. The principle that we follow at Altropy is that we need to break down your AI feature into these smaller tasks, and there's the benefits of the software engineering side of things, of the building things, and even reasoning about what's happening inside your application. But also, this allows a tool like Altropy to be super smart when it comes to how in building the pipeline for you. So basically, Altropy can build, run, and optimize the pipeline for your tasks. And the way we do this is kind of very declarative. So basically, you have a few test types you can pick. We're going to explore later. You define input type, output type, and these input types and output types, it could be, in case of Ruby, it can be literally just a class. It could be an active record model. We just released our Rails integration that allows active record to talk to Altropy very easily. You give it a prompt, this kind of instructions, some reference data. Hey, use this information from these and these and these data sources, which constrains the pipeline looks at, and maybe some guidelines. Basically, if you look at it, it is very similar to structuring what a very long prompt would be. We have a lot of people come to Ultra after developing their own features or AI features for a while, and what you see invariably is that these folks end up with like a 200 lines, 250 lines prompt where they try to do a lot of these things. The way that Ultra works is that we don't have one super prompt. We, like I said, build a pipeline for you. This is an example that I got, I think, last night from a real pipeline that Ultra builds. And as we're gonna see, if you go through the UI or through the API, you can look at each individual component, see how it's configured and all that. And because the most interesting thing about Ultra not only it enables this style of development that we believe works much better, but it also has a query optimizer side of it. So basically, every component you see in a pipeline, it's been configured by Ultra over, it does some multivariate testing, tests different options, finds one that works best for that particular case, but it keeps testing and it keeps trying. And if your data shapes a little bit, you used to send CSV files with 10 lines, now we send CSV files with 100 lines, it will automatically reconfigure itself so that you can be sure that you're always using the best pipeline for each specific data. Obviously it takes some time because it needs to train a little bit, but by using reinforcement learning, we can actually shorten that a lot. If you're used to A/B testing, if you have this culture in product development of using A/B testing and multivariate testing, it can take a while to have any statistical significance, but with Ultra we're able to kind of bypass this using some reinforcement learning and embedded algorithm tricks. You don't need to know anything about that, but I always like talking because I like saying bandit. Okay, so now let's go for the tutorial.